Hello and welcome to another daily Leetcode challenge. Let's begin question 74, search 2D matrix. Stick around for the end of the video where we compare our answers to answers of those in the other solutions, see what things can be improved, how other solutions might be better or ours could be better. Question 74, search a 2D matrix. You're given an m by n integer matrix with the following two properties. Each row is sorted in a non-decreasing order. The first integer of each row is greater than the last integer. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in the matrix or false otherwise. You must write a solution in O log m times n time complexity. Just before I say anything, this right here is almost a straight giveaway that this is a binary search. Binary search time complexity is O log of n being the number of elements in the array. If we figure out that this matrix is actually just a sorted array, which it seems like it is because of the property of the first element in each row being definitely bigger than the last element of the previous row, and that each row's numbers are sorted, it could just be a sorted array. So with that, let's see if we're correct about that. And yes, it really just does seem like in the example this is a sorted array, just broken up into almost subarrays. And if we're given a target, then pretty much all we have to do is go and write a binary search. So I'm gonna do that. I'm gonna say start off with having the from having the dimensions of the matrix. I'm also going to have something called low and a high variable. The low and the high are really just variables that are going to be used in the binary search to mark the boundaries of the array or the subarray that we're currently searching. M times n times n minus 1. So this is low is pointing at inclusively pointing to the start of the subarray that we're searching. High is pointing to the right bound inclusive of the array that we're searching. And now finally, while low is greater or equal to high, this is our while loop that we're going to be iterating over as we try to get the subarray as low as possible. And yeah, that's it. Mid is going to be our low plus high divided by 2. Divided by 2, double is to get a integer instead of a float. Let's have a mid number. Okay, so yeah, there's this intermediate step or this modification to the algorithm, because you have to get almost a you have to figure out where in this matrix we're currently where in this matrix the low and the high are, and therefore the mid value is. But mid value is actually just matrix, and the row that we're looking at is actually mid divided by 2. And within that row, the index is mid module 2. And I don't know why I said 2. This is mid module, not 2, but m, and mid divided by m, mid module m being the length of one of these arrays. And so if you were to divide, what is this? This is 12 by 4. Let's say that mid is 7. If you were to divide 7 by 4, you would get 1. And so you would know that you're in the first, or 0th matrix or row. And then module 7, 4 is going to be 3. So you almost, you immediately know where the where the value is that you're in the matrix. And then we have a condition that if mid val is equal to target, then return true. I believe we only have to return true or false. And then if mid val is less than target, then we set high to mid minus 1, and it's going to be an elif mid, and then if mid val is greater than target, then we say low is equal to mid plus 1. And I hope it's clear what's happening here. Once we get the middle value of our subarray that we're looking at, we want to eliminate half of the subarray immediately. And since the array is sorted, we could say that if the middle value, this mid value, is equal to the target that we're looking at, great. Say that we are that it's true, that this value does exist in the matrix. If it doesn't, however, we could automatically discard half either all the values to the right or either all values to the left. In this instance, we are discarding all the half of the values that are to the right of the middle point. And so we actually just set high, our right boundary, to middle minus 1. Else we set low. Else, if the value of the target is bigger than the value of the middle, then we discard the left portion. And that's it. This should run. This should run correctly. This is a very complex, and I always miss this. This is a pretty easy modification to the binary search algorithm, and let's see what's going on, what we're doing wrong. Output false, even though this is true. So what happens very often in here with me is I get mixed up with the m's and the n's. So let's see if that's what happened here. So I want n to be the number of rows. I want m to be the length of each row, and that's correct. Then low and high are going to be, low is going to be the left bound, which is 0. High is going to be the right bound, which is m times n minus 1. And then while low is lower or equal to high, I'm going to say low plus high divided by 2. That's going to give me the middle. And I'm going to say that mid value is going to be, okay, and now here, matrix, the first index in the matrix is going to dictate the row index. And if m is equal to 4 and mid is equal to 0, 1, 2, 3, what's good? What's going to be the first? The first is going to be 11 divided by 0, 1, 2, 3, 4, 5. It's going to be 11. So mid should equal to 11 minus 11 divided by 2, which is just 5. Mid value should be equal to 11. Mid, if mid is equal to 5, then 5 divided by 4 is going to be 1. So 0, 1. And mid module m, that's to get the other index, that's going to be 5 module. Okay, so this is actually just 1, 1. 5 module 4 is also 1. So 11 should be the value. Let's see if that's what we're getting. It should be 11. Then after 11, it should be. Well, actually, let's not guess. Let's just run it. See where this is going wrong. 11, 23. Yes, it's definitely not correct. Did I mess up? $11, 23, 30. 11, 23. What is going on? Let me print, instead of printing just the value, I also want to print low, mid, and high. This is correct. 11, 5 is the middle, and 0 is the left bound. In this instance, I should be saying that since the target is 3, I should discard. Oh, yeah. Okay, well, I messed these up. If target is smaller than mid val, that's right. So I had the if statement incorrect. Let's sound this out. If mid value, if target is equal to the mid value, meaning that the target that we're searching for is the mid value, then return true. If target is smaller than the mid value, that means that our answer is in the left portion of the array. And so then we set the right boundary to high, right boundary high to mid -1. Else, it's in the right section of our answer, and low is equal to mid +1. Let's run this one more time. This gives us the correct answer. And hopefully, let's try. Great. Awesome. So besides that hiccup, pretty smooth solution. Okay, and now we're ready for the comparison. So since we now have the answer right here, let's see what other modifications did people make in order to make their solutions run faster or be more readable. Great. So in here, the topmost solution, the 0.01%, is some modification to the. I see. This is a very standard layout for a binary search, a while and then a lower bound and a higher bound, and it seems like here the person is using 2 loops to maybe first to find, I wonder if this is O log m plus n rather than log of n times n. And that would actually decrease because m times n is almost always bigger than m plus n. Vertical, low, vertical, high. Vertical low and vertical high are boundaries of the rows. Horizontal high and horizontal low are boundaries of the row. So let's see what is happening here. In the first binary search, it seems like vertical mid is same property, vertical high plus vertical low divided by 2. If target is greater than vertical mid so vertical mid is just a, so here's what confuses me. Vertical mid is supposed to be looking at simply a row index. Like it's simply one of the n number of rows that are in there. So vertical mid should not be giving us a, oh, vertical mid is just giving us the row index, like which row to use. And for the value, they're actually using horizontal high. Horizontal high is the value, and if target is bigger than horizontal high, then use vertical low, update vertical low to be the vertical mid plus 1, meaning that no, we're discarding half of the rows right away. I see. And then if target is smaller, then okay, but here this is a little bit odd. If target is lower than matrix, oh, and here he's using the, I see. This is a very interesting modification. This is what is going on. In the first loop, these two if statements, or this collection of conditions, eliminates the rows at a pace of O log n being the rows. The way that they're doing it is they're looking at the end boundary of the end of the previous row to eliminate rows, all rows that are lower than a certain, all rows with values that are lower than a target, and they're using the horizontal low to eliminate rows that are greater than the target value. Once they find the vertical mid being this search rows, they're now doing O log of n, n being the length of just the length of the row. And yeah, and this is a very this is the same approach as the previous one, except here they're doing binary search over the row. And this print statement is actually probably messing up the solution quite a bit. But to be completely fair, the solution is, or the description is asking us to solve it in O log m times n. I wonder if there are modifications to this problem where it's asking to solve it in log m plus n. But nevertheless, I would say that this approach is in line with the description. And yeah, so use this. Very, very standard if you want. Okay, so that was our comparison of our solution, my solution versus others. Feel free to use this, and see you in the next video. Goodbye.